We're given an octahedron, which is basically two square pyramids attached to one another. So let's get that drawn. And we want to find the surface area. So we want to find the area of each of these triangle faces. Now, because the cube has side length 12, that means the height of this triangle is going to be, sorry, the pyramid is going to be 6, because I just divide by 2. I've got a pyramid at the top and the bottom, they're exactly the same. Now, to find the area at the face, what I really need to do is know the base and then the height. Okay, I'm going to start with the base. That's a little bit easier to deal with. This is a view from the very, I put it up here, from the very top, looking down. And you're going to see this shape kind of, it's at an angle, it's 45 degrees either side, or 45 degrees relative to the main square. So if I just focus on one of them, this one here, this is the red amount, actually it's going to be here. And we've just said that it's 6 in height. It's going to actually be, this is also going to be 6, okay, because it's 12 in total. So that is 6 and that is 6, meaning that this ends up being 6 root 2, because we square them. 6 squared plus 6 squared, that's 2 times 6 squared. Then we square root it, which nicely gives us back to 6 root 2. It's worth knowing that if ever you have a 45-degree triangle, and you have x and x, you just times by root 2. 6 root 2, that is the base then. Okay. Now I'm going to drop a perpendicular down to here now, and we actually create a right angle triangle. So remember, this is coming down from the face. Here, this is my right angle. If I look at it from the side, it'd be like that. And what I'm going to have is 3 root 2 here, because it's just a half of the 6 root 2. I've got my height of 6. That is that one there. So I just need to work out this red length, because that is basically the height of any one triangle. So I can use Pythagoras' theorem here. 6 squared plus 3 root 2 squared, square rooted. That's 36 plus 9 times 2, that's 18. Be careful with this, 54. What does that give me? What goes into, so we're going to have 9 goes into that. So it's going to be 3 root 6. I'll leave it like that for the moment. Okay, but that is this length here, 3 root 6. So actually we are finally there. The surface area, well, one triangle is going to be a half times its base, 6 root 2, times its height, which is 3 root 6, which actually I'm now going to write as 3 root 2 root 3, because the root 2's are going to come together. And I just need to then times by 8 to get the total surface area, because there are 8 triangles. The half and the root 2 and the root 2 are going to cancel. That leaves me 8 times 6 times 3. So that is, what should I do? Which is the best thing to do? 48 times 3. That's going to be 144. So 144 root 3. Finally, what is the value of a plus 10b? Well, a is my 144 and b is my 3. So it's going to be 144 plus 30. Give me a final answer of 174. Quite involved there. You'll be really careful. Hopefully my drawings have made sense. Well done. Just one thing to say at the end. I didn't really think about it when I did this question, but it turns out that the triangles are all equilateral, and it's because they're inside a cube. But you can have an octahedron which without the triangles being equilateral, and that's kind of what I went with, the general method. But in this case, because of the symmetry, the fact that you've got this in a cube, they are. So you can spot that, it just saves a little bit of time, because once you've got your side length of 6 root 2, then actually you can just say, you know what, here we go. They're all going to be 6 root 2 like this. And there's a 60 degree. I can just use a half AB sine C. So half times 6 root 2 squared times sine 60. And then because I've got 8 of them, just times by 8. This is going to become 4 times 36 times 2 times root 3 over 2. Cancel that out. Again, we get 144 root 3. That is a nice way to do it, if you can see it.